we are doing 10.3, but I would look at the old version that I did before because they're only doing about half of what needs to be, what was originally in there. And I'm glad, what I do is I have a habit of, I go in and look at what's on the homework. The homework only has limits at infinity for 10.3. No factoring, that's what I thought they took that out. And there was a conversation, I've been out of the loop probably for the last year, because this is, like I said, I haven't taught this specific class, but there was, I was hearing complaints about there was too many people were not passing or getting a reasonable grade. So I know there was a discussion with the provost, and the class was revised. I think they had to take a look. Do we really need to teach this? If we don't, let's take it out. Let's put a class that people can be successful in. Last time I taught it with all the other stuff in there, average grade was about a B, 80%, which is good, which means, and so I think we'll do better this time even. So there's a lot of things that, again, we're going to focus on the conceptual part, knowing that this is a math class for business majors. So that'll be our focus. So anyway, what I've got going so far, I'll start doing new sections for each day that we have class. So 10.3, or Tuesday's class is in here. There's the recording from that class. There's also the older recording, which I also got an email that to take out questions 5 and 6 from 10.1. If you've already done that, that's fine. If you didn't, it should rescore it. But those were taken out this afternoon. If you haven't done 10.1, you'll see there's only 8 questions instead of 10. But that's what we were supposed to do, because those 2 questions dealt with continuity, which we're not talking about. We don't really need to. And so that means that for 10.3, about half that section is gone. And so what I've done under this section, I still have the old video, but I do put this that only limits at infinity are covered. So you could, if you wanted to watch this, you could go about halfway through and find it, it limits at infinity. But today's lecture, I've updated, I got the new slides, cut out everything that isn't in there, and we're only going to take a look at limits at infinity. Okay, and we'll do it in a little bit deeper than was done originally, because that's how we're going to be doing. So these slides, I'm now going to be using Google Slides. So I import it there. It's a little bit easier for managing and recording and all that kind of stuff. So if you click on this link, you'll be able to open them up as well. You'll get the blank slides. What I'll do is, as I do the lecture, I'll write on them, and it's being recorded. But you could come back and take a look at the blank slides as well. These are the ones that the textbook provides. What I was doing on my other slides is I would actually go into the textbook and I would take some screenshots from the book, get a little bit more detail, but we'll make do with these particular slides for tonight, because really tonight is nothing new, but we're going to revise it a little bit. So it's limits at what happens at infinity. So where we left off on Tuesday night is kind of where we're going to pick up. We'll look at some specific examples. Come on in, it's fine, no worries. We'll make it all work. So we're going to look at some specific examples and a little some exponential. What happens when, like, we've got an exponential function going to infinity, and it's either this or it's that, and we'll look at those simples. And then you'll be able to really just go through the homework. You'll still be able to do the homework with using the numerical approach, looking at a table and then just putting in like 10 million. Where is it at 10 million? Is it getting bigger or whatever? So you can still do that. You could look at the graph, but we're also going to just take a look and sort of see some algebraic methods, which are going to be pretty simple. So limits at infinity. First, I guess before I get going too far, any questions that have come up about anything? No, I don't know the lottery numbers for the Mega Millions. I wish I did, because that's it's almost $1 billion. It's over $1 billion, right? Next drawing. What's that? No. I bought a ticket for 5 drawings. I thought in one of those 5 drawings I'd obviously hit it, but yeah. Well, I don't know. I have so much fun doing this. I wait till the end of the semester, but Yes.
Could you possibly go over one of the problems from 10.1?
Sure. It's a good time to do it because, like I said, you're gonna see tonight's. We've done most. Oops, I don't want to stop it. I want to keep recording. There's going. Let's see. So and that's kind of why I do have. Oh. Before I do it, so I'm going to do one in 10.1. While I'm here, I want to also highlight you do have a book. It's an ebook in here. So because I know some of you contact me said that the book was like $200. The printed book might be, but you don't need the printed book. You have this ebooks anytime you want to look something up, and it's actually a good way to go through. But again, you could go through the book for 10.3, but the first half we're not doing any of those types of problems, and you wouldn't know that till I didn't know that until I checked the homework. So I don't know. For me, I would probably wait till the lecture comes out because I don't want to do a bunch of work that I don't have to, right? And it's got, we start at chapter 10. So you can come in here, and again, it's just, this might be a helpful resource for you if you learn by reading or you need to see more examples. Oh, I do want to show you something. So here's 10.3. This is actually to the end. So, it's got a lot of stuff in here. And the nice thing with the ebook is you can click on things and it'll give you like the example. But here's another thing it does have is it's got a bunch of homework problems. So if you get stuck on a homework problem, you might want to come here. And the cool part is that on all the odds, it will give you the answer. So if you had something similar to this, you could click on this and it tells you what the answer is. So there's something, basically additional examples here, all the odds. And it's like with an ebook, you don't have to flip to the back of the book. You just click on the button and it'll give you your answers for each of these. So this doesn't exist. So you look at it, oh, okay, why? Because it's going to 0. So we're going to go over some of these, but there's a nice way to take a look at similar problems, maybe from the homework would be in here. And then where do I want to go? So we're going to come back. You want a which question do you want from 10.1? Question 4. You got it. And again, when I pull up my question 4, let me see if I can make this a little bigger. Good. This is kind of one we're getting into tonight too, an exponential. And again, what you see these red numbers mean that on your problem, when you pull it up, those are randomized. Your numbers may be slightly different. So, but that's the only part that's changing. So we're letting x go to 5. So again, this one, it says do it numerically, so what they're really saying is put in your calculator, look at the table of values, what's happening as x goes to 5. So look at 4.99, 4.999. But let's go to the shortcut. If we plug in 5 here, are we going to get a value? Yes, it works. And actually, that's the first part of this lecture we were going to do tonight that we're not doing. It just says, for problems like this, these are continuous, and so when doing limits, you could just plug it in and you're going to get the limit as well. Okay, so this one we could just do by calculating, plug the 5 in, put this in our calculator as 4e to the 5th minus, oh, wait a minute, you don't even have to put it in the calculator, except 5's up in the exponent, right? What's 5 minus 5? 0. What's e to the 0? 1. Anything to the 0 power is 1, except for 0. 0 to the 0 is one of those things we don't really know what it is. But anything to the 0 power is 1, so this is 1. What's 4 times 1? 4. And so we could do it that way. Let's see if it worked. Put in our 4. We come to the end. We're going to submit for testing, which then it will tell us, and it says it's right. Did that help? So again, now from the textbook it says, put it in your calculator, look up 4.99, 4.999, and what you would see is your answer, your y value keeps getting closer to 4. It was probably 3.9, 3.99. And then if you go a little bit bigger than 5, you'd see from the other sides it's getting there. That's the concept we're going with, but the quick way is with these kind, we can just plug it in and go. Okay. So, and that's the way is, if you can come up with the right answer, you're gonna, sometimes it doesn't tell you that you can do that it works, but later on it would, this 10.3, it's gonna tell you, yeah, that's a valid way of doing it. Once we have a valid way, we can always use it. And if you know a valid way from previous times, you can use them, even though they might not have, like in 10.1, they didn't teach us that yet. Okay. And again, you should be, I checked my other class, if you miss, they give you like 5 attempts, but they were doing a 10% penalty each time you miss it. I didn't see that in here, but if you notice that you missed a question and then you got it right the second time and it didn't give you full points, let me know, because that's not the, I don't think that this system does it, but if I'm wrong, let me know. I'll fix it. Okay, we okay? And again, we've got till Monday. I saw about 63 of you were in the afternoon were registered, so maybe a few more of you will be adding in. That's fine. We'll get it up and running and we'll make it all work. Main thing is if you can get started within the first or second week, we're going to be fine. I know they say get started day one, but reality is we can, as long as we get moving, we'll be fine. Okay, so these are the examples we're going to look at. And that's really all, I guess I should go back. It's limits at infinity. This is the only section we're going to be looking at from this part of the book. We're going to look at each of these, and by looking at each of these examples, we'll pretty much be able to do all of the homeworks. All the homeworks will have variations of these problems. So we're going to focus on Tuesday, what we said is when we have a ratio, like looking at this first one, what is the things we need to worry about? What don't we need to worry about?
The smaller exponents.
Don't sweat the small stuff, right? Yeah, it's just worry about the big stuff. And so we get to say, so just we look for the biggest exponent. Everything else we just say, we're not going to worry about it. Now, it's not that it's not important for the function, but because we're looking at what's happening out here at either positive infinity, negative infinity, we don't really care about the middle stuff. Okay. There will be times when we need that middle stuff, so don't, when that's the question, but this is what's happening way out there. Okay, so we don't sweat the small stuff, we look at the little stuff. And so algebraically it becomes much easier. It's 2x squared over x squared, and then we can do some simple algebra. No need for factoring or anything, but x squared divided by x squared is 1. So we do that. So this is now just a constant. It's 2. Can 2 be anything other than 2? No, because the variables have canceled out. So this is going to have a limit of 2. So that's one way we'll do those. And we'll go through some of the slides, actually do it sort of more painfully, step by step, and showing you these things. But that's what we're going to do with each of these. And each is a little bit different. You'll see sometimes the exponent on the top is bigger than the bottom. What happens then? Sometimes the bottom's bigger than the top. What happens then? Sometimes they're the same, and sometimes we have exponents. So we're going to look at each of these, and then we'll be able to do our homework. Will give us variations of these. Okay. So basically, this is just saying that just look at the big numbers. Look at the highest degree. So x squared, x to the 5th, whatever that highest exponent is, we just focus on that term. We can ignore the rest of the terms. Okay. And it's just telling you when x, so a number like 2 to the x squared, when x gets really big, let's see, where are we? Oh, actually, this is talking about a and b. So, 2x gets so big, it doesn't matter. The 4x, it's big, but it's not big enough. I mean, it just doesn't. So we ignore the 4x like we did. And the same thing on the x squared term in the bottom. Minus 1 is so small, it doesn't matter. Infinity minus 1, you're still pretty close to infinity. Okay, so that's why we, again, just don't sweat the small stuff for all of these. So this is the explanation for what we just did up here. Don't worry about 4x, don't worry about negative 1, just look at the first term. Okay. And then when they're the same degree, x squared and x squared, those are going to cancel. So it's really just the ratio of the numerator denominator. So it's, you know, thinking of it, it's really 2 over 1, which is just 2. Okay. And so that's what they're showing us here. Algebraically, we're not even talking limits here, but we're just saying we know x is going to be getting huge, going to infinity. So we just do that part. And so our limit's equal to 2. We okay with that? Anyway, we could use the numerical way and put this in and see what's happening way out there at, you know, 200 million, and we'd see, hey, it's getting close to 2. Okay, so, and if you look at the graph, what you'll see is out there, it somehow either comes down to it or goes up to it, but the graph eventually is going to be looking like a straight line at y as y equals 2 when we get out there. Okay, so all those things. Oops. So that was that. And then we're going to look, their example C. Now notice the degrees are not the same, but what we do is we still do the same thing as we ignore anything in the top or the bottom that is not in the, you know, we're only going to look at the top part. So now we do the same thing, right? We've got our x's can cancel. We got 3 x's in the top, right, x to the third, and 2 x's in the bottom. So 2 of these cancel out with 2 of these, leaving us an x to the 1. Does that make sense? Okay, it just makes algebra real easy. So what we really have is we have something that looks like negative x over 2. Now, when just thinking about it, when x gets really, really big, if you take that really big number and you divide it by 2, where are you? You're still big. You're half as big, but, you know, what's half of infinity? Well, infinity's so big you can't ever get there. Half of infinity still huge. Okay, so what we say with this one is it's, where's it going? Well, the y value is also going to infinity. Half of infinity, but again, infinity's so huge, yes.
Wait, but wouldn't it be negative though? Because
Thank you. So you caught my weakness again. I don't pay that much attention to the negatives like I should. Yes, you got it. It's going towards negative infinity. Thank you. So one of the answers is when it goes, it diverges, right? The limit doesn't really exist. But another thing is sometimes we want to know, you know, from the context, does it go to negative infinity or does it go to positive infinity? And in this one, they want to say, well, when x goes to infinity, y goes to negative infinity. Thank you for that one.
Would
Yes.
it also, would it be reversed if it was negative infinity? Like, so if it was...
Exactly. So if
It's
we...
the stuff I got wrong last semester.
Yeah, I'm with you. I always, because I understand it in conceptually, but looking at the negatives. So if we change this, if the limit, if x was going to negative infinity, then we're thinking, well, we plug in what's a negative of negative infinity, that's going to be positive infinity, right? And again, it's over 2, but 2's, you know, divided infinity of half, it's still huge. It's still huge. Just like Elon Musk, right? He lost, what, 200 million? Or 200 billion. He lost so many billion. He lost more money than all of us will probably ever make. He's still rich. Still a billionaire. Okay, so yes, so that's the thing, start watching the sign. One of the things we want to look at, especially with, yes?
So how would it just be negative infinity? That's just the answer.
Yeah,
So
that's
we
what
just
they're
put that down, that's right.
Right.
Okay.
As x gets large, it's magnitude negative, so the limit is. And sometimes these are, that's why you also get those multiple choices or multiple tries. So if you put this in and you're not quite sure, put something in. And then it'll tell you, oh no, that's not what we wanted. Okay, I put in D and E, does not exist. Oh, they want that it actually goes to negative infinity. Just be careful. Yeah, if you put positive infinity, it would mark it wrong. It wants negative infinity. So also, one of the things we want to look at is when do we have to...
I found this on the web.
When do we have to worry about... Yeah, it never suggests anything other than when I'm teaching. When do we have to worry what kind of exponents, if we plug in a negative, gives us a negative value? Not negative exponents. Negative exponents makes it 1 over, but odd, right? One power, third power, fifth power. Because those will give you an odd number of negatives. If you plug in a negative, you get a negative out. If you have a even power, squared, fourth, what's always going to happen, you put in a negative value, you square it, it's going to be positive. Fourth power, it's going to be positive. So watch that when you're plugging, when it says the limit as it goes to negative infinity. We can get a little sloppy, and that's what I do when we're dealing with even exponents, but when we're dealing with odd exponents, we got to be careful here. So yes, good. And also when there's this negative sitting on the outside, pay attention to it. Okay, but we're good. So if the degrees are not equal, then if it's the bigger one's in top, it's going to go off to infinity, either positive or negative, depending upon that. What if, I think the next example, what if the bigger degree is in the denominator? Ignore that, ignore all of that. So we just have this part. X squared is going to cancel here. 2 of those are going to go, so this is going to be 5x in the bottom. So we end up with 2 divided by 5x. Now when x gets really big in the denominator, what happens to the result? Very good, yeah. So 1 over 10th is 1/10. 1 over 100 is 1/100th, is a penny. So this is a dime, this is a penny. 1 over 1,000 is, so yeah, we're getting smaller and smaller and smaller. And what's the smallest number you can think of? 0, right? Actually, negative numbers, negative infinity is probably the smallest in magnitude, or value. But yeah, I think 0, if we take off, yes?
So why you skip the whole things up here?
Because we're looking at x squared is going to, when x gets big, x squared is going to be so much bigger than 4x, we don't even have to worry about it. It's not that it doesn't, again, if we're looking for a value, we may need to have that in there if we're like close, in the middle. But when we get out to the end posts, it's not even in the game. Even if we had x to the 1.5, x squared becomes so much bigger at infinity that we only look at the largest. And actually, it's sort of like that's the theorem that they give us at the end. They tell us it's okay to do that. And this book is kind of like that. It'll give examples, and we'll go through it, and we'll explain it. It doesn't give the math behind it. It doesn't show a proof, but at the end it'll say something that kind of looks like a proof. If it looks like this, only look at the biggest one. Okay. And so yes, 2 over 5, and again we can just kind of click through here. The denominator gets so big, 2 over a big number is actually going to go to 0. So think of it as 2 over infinity, and towards the end we're going to compare things like this. If you've got some number over infinity, that's going to go to 0. Okay. The last one, but basically we had infinity over a number, it's going to go to infinity. And again, either positive infinity or negative infinity. You okay so far? And good. And yeah, if you have questions, ask them. Because if you have a question, probably somebody else has a similar question. Okay, now we get to exponentials. And so now, here it is, it's a little different. E is a number, right? What is E? Does anyone know what the value of E is? It's a natural number. 2.718 something something something. That's as far as I can get. I think it's 8, but yeah. So it's almost 3, but it's something called the natural number. You use it a lot in business because in finance it comes up. It's for continuous compounding, and so we'll use it. But so this is, you could think of it, it's like 3 to some power. And even though this is getting multiplied by 0.1, if you take, again, thinking, if we take a really big number and multiply it by 0.1, what are we going to get? It's a little bit smaller. It's right 1/10 of it. But if I'm at infinity, what's 1/10 of infinity? Well, that's still a pretty big number. Okay, so it's kind of this is what's happening when we multiply. It may be smaller than what we started with, but it's a big number. And if you take, how exponentials work, right? And again, you could just think this is like 3 to the infinite power. That's going to be pretty big, right? So does it matter that we're subtracting 20? Well, again, what's infinity minus 20? It's still infinity, right? So, infinity's so far out there, we don't sweat the small stuff. So this is going to give us something like something to an infinite power. That's infinity as well. And again, here's what I found. There's no negative signs or anything, so we're going to say that that goes off to infinity and actually goes off to positive infinity. And again, they used E, which is exact value, but I like when I see E, I think that's close enough to 3. Yes.
When you make a test, are you gonna check on how you write it? Or if like I just wrote plus infinity, would you?
Oh yeah.
Okay.
Yeah, if you're on so here, the tests, there is going to be multiple choice portions, so you'll just have to choose the right answer. That's easier to do. There are going to be a few open answer ones where you do right things, and yeah, if you can, I'm looking, does it look like you're on the right track?
Okay.
If you're off by a negative or something, again, negative infinity is very different than positive infinity, but I understand when you're working through a test and you got stress, because that's where I was at too. So yeah, you'll, maybe out of 10 points, you'll get 9.5.
Okay.
Something like that, yeah. You're not going to get 0 points for having plus infinity when it was negative infinity. I'll get you. Yeah. We're looking for overall. So far, so good? Okay. And this sort of the last one from those examples we were looking at. We have to remember from algebra, what does it mean to have a negative exponent? It's what? You're dividing by it. It's sort of reciprocal. So, and they'll show that here, but it's really, when you have this negative, what it's doing is it's 1 over 3.68 to the t power. So t is going to go to, the variable is going to go to infinity. So what's 3 to the infinite power? Infinity. And so, but what we're really getting is we're getting 1 over infinity, right? So in the denominator, let's see, I'm going to click one more time. Here we go. This is the function we were dealing with. So this whole part here, right, or this little part here becomes 1 over 3.68 to the t power, which is 1 over infinity. And again, we sort of, yeah, if it was by itself, maybe we could flip it up, but because it's got this plus 1, it's just down here. So what's going to happen to this part here? It's kind of, sometimes we got to just look at the pieces and then we put it back in there. 3.68 to the negative t, I think it's going to be 1 over 3.68 to the t. So that's going to be like 1 over infinity. What's 1 over infinity? 0. Okay, because it's 1 divided by a bigger and bigger number, we get closer and closer to 0. So we just got to remember that's going to be 0. So this little part here becomes 0, and that's what they put here. And then now we actually do have to pay attention to all of these. So it's a little different when we have an exponential, okay, because it's a negative exponential. This goes to 0. 2.2 times 0 is 0. So now this is 1 over 80. And so the limit, as the variable goes to infinity, the whole statement actually is going to end up going to 80. See how that is? This little part here goes to 0, right? 3.68 to the negative infinity. That's going to go to 0. So then we put that back in here and makes part of it go away, 80 over 1, so it goes to 80. So it's a little tricky there, but negative exponents, just think it's going to make a reciprocal. If it wasn't a negative infinity, or if this wasn't negative, what would this go to? This would go to infinity. What's 2.2 times infinity? That's still infinity. What is 1 plus infinity? That's still infinity. So then you've got 80 over infinity, which goes to 0. Okay, so all the difference between whether that was a plus or a minus. A minus, this part goes to 0 here, and then so the whole thing would go to 80. Had it not been, the whole bottom would have went to infinity. 80 divided by infinity, the whole thing would have went to 0. Okay, so just kind of, and the last few slides are going to give you basically those kind of rules of when you get this kind of a number, it either goes to 0 or goes to infinity. Okay, and again, this is now they go ahead and tell us that we can do what we've been doing. So this is a lot of mathematics, but what it's just saying is the top part, here's the top, the biggest degree is n. Notice this is n minus 1, so all of these are smaller. We get to ignore them all, cross them out. In the denominator, the biggest power is m, because this is m minus 1, and so forth. So we just ignore all of this stuff. And when we go to examine this of what's happening at infinity, we only look at the biggest degree in the numerator, the biggest in the denominator. And so this is basically saying that what we've been doing is okay to do. Okay. Just look at the biggest values in the top and the bottom. Okay. Again, that's with a polynomial with a x to a power. It's not with exponentials, e to some power or any other type of exponential. We're going to look at that kind of, I mean, we looked at those two examples, but basically we're able to do that. And then again, just be careful with the plus and the minus. Again, if these are odd exponents and you put in a negative, it's going to stay negative. If they're even exponents, it doesn't matter whether you put even or odd, they're going to become positive, right? And then just look at the leading coefficients, they might have a negative in front of them too. So just kind of watch for those things. Okay, so, and again, they went with a quick example. It's I think where we started. So we're just looking at this part. Those guys cancel. It really is just 2, because all the variable parts cancel out. So this is where we get some listings of what they call indeterminate forms. And this is kind of what we were just talking through, right? If I have some number divided by 0, that actually gets me to infinity, right? When a division by 0 is usually said it's undefined, but if I were to define it, I'd have to say it gets me to infinity, either positive or negative infinity. So we were kind of making a case of that. And again, it's thinking I've got some constant number, k, whatever, and I got the denominator is getting really, really small. What ends up happening is the result is really, really big. Then we kind of talked about these in general. If I've got some constant number times infinity, I'm still at infinity. If I take some number and I add it to infinity, I'm still at infinity if I add or subtract it. And again, I just, depending upon, I watch the signs. If this is negative infinity, then I'm still at negative infinity. Okay. So infinity is such a huge number, distance. The concept of it, it's not a number, but it's sort of a destination. It's so far out there, you can't do anything to pull it back. Okay. Now, if you're interested, there's a book I read, or started to read, called The Keys to Infinity, and it talks about infinity. And there are infinities that are larger than other infinities, but that's kind of, if you start going down that road, it's almost like a theology. The math becomes theology of, well, is there an infinity or is there not? But there's a whole consideration. We're talking about these, so if I've got infinity and I divide it by a constant, we're still at infinity. So I divide it in half, I've got half of infinity, but it's still so big that we're still at infinity. But if I take a number and divide it by infinity, right, because as the bottom gets bigger, I get closer to 0. So these are just concepts that we were talking our way through, and this is just sort of summarizing, yeah, that's what happens. You have a number divided by infinity, that's going to be equal to 0. And just kind of, you think numerically, that's the pattern. As a denominator, 10, 1/10 is 1/100th is getting closer and closer to 0. And then here's where we pick up the exponentials. So if I've got any base and I raise it to the infinite power, I'm at infinity. I mean, it's going to happen. As long as the base is larger than 1. What would happen if the base was lower than 1? Then I've got a fraction. What happens when you take a fraction less than 1? What if you repeatedly multiply? Let's just even take 1/2. What's 1/2 times 1/2? 1/4. We're getting smaller, right? 1/2 times 1/2. We have 1/8, 1/16. So we're going to get smaller. So if our base is less than 1, that's the one case, and I take it to the infinite power, I actually go to 0. And that's really what's happening here. If k was bigger than 1, remember this negative exponent just means I'm taking a reciprocal. It's really saying I'm getting 1 over k to the infinite power, and which is, that goes to 0, okay? Right, so, and also the same thing is if k is between 0 and 1, when we put it to the infinite power, it also goes to 0. Okay, is that kind of making sense? And again, you can, one of the things I do is, even though on the test you can't bring notes in, I bought these 4x6 cards, not the little cards, the kind of bigger ones, cardstock, because it's nice. And I would put stuff like this, nicely organized in the corner of the card. And then when I did my homework, I just put it out there. I'd have it sitting there. So if I ran on something, I didn't have to go look it up again. And I didn't have to try to memorize things, because I found when I tried to memorize things, I wouldn't, it didn't work for me. But if I just sat it out there and oh, yeah, it's that. I'd look at it a few times, and after a while, I didn't need to look anymore. Then I remembered. Okay, so give it a try. But some people say, well, I can't use notes on the test, so I got to learn it with not having notes. Well, that's not necessarily true. If you use the notes, it'll get there. You always bring your head into your, well, hopefully, and so the first thing, and then what you can do on the exam is on your scratch paper, do what I call a brain dump. Just write down all the things you remember. So, and then just some quick examples. So does it make sense that if x goes to 0, what's going to happen here? We're going to have division by 0, right? When we divide by 0, where do we go? Infinity. So now, instead of saying it's undefined, we're really thinking, no, when I divide by 0, when that denominator gets small, we're going to go to infinity. Wouldn't that be cool? If you're running a business, all I got to do is get that denominator to 0. We're infinite millionaires. So I don't know where that fits in, but so then as x goes to negative infinity here, what's going to happen here? That would be negative infinity times 3. Do we even worry about the minus 5? No, we don't even really worry about the multiplying by 3. We're at negative infinity. We're going to be staying at negative infinity. Okay. And this one, it's in the numerator, so basically just kind of plug into infinity. We're going to multiply it by 2, divide it by 60, but again, infinity is so big it doesn't matter. It's still infinity. So it's just kind of, that's how these things work. Some basic rules. And this is kind of, go ahead and write it out. That's really what's happening. So when I got infinity times 2, it's infinity. Now I divide it by 60, it's still infinity. So big that just nothing touches it. Oops, can't go anywhere. I guess that's the last slide. So you see what I mean is, it wasn't anything really too new. We kind of got onto it the last class, how we were doing it, but we did look at a few examples. Shoot, we got done more than a half hour early, but that's fine. So, and I think there was a few more homework problems. I don't know, maybe 16 I was going through. There was just go through them, but they're all like this. A few with exponentials. There's one where you've got 2 that you're being subtracted, and it's a little wordy. I tried it, but kind of follow through, give it a try. If you get it wrong, it's nothing lost. Try it again. Doing good? Okay, so, and again, this is recorded. I'll post this one. This is going to be the better than the old one. You don't have to see all the other stuff. We'll just keep moving forward. Just get registered for the Webassign if you haven't done so. Try to get it all done by Monday night at midnight if you can. And then with Tuesday, we'll pick up with the new stuff. Hi.
I paid for the book, and then it like works, and then now it's now 11 on the book, and I didn't pay for it, and it went through my card instead of charging $100.
They make sure you're using the right. I saw someone else did that because when you sign up for the first time, it gives you like a 2-week no cost one. But since you paid for it, there might be another icon. So make sure you're getting it.
And then one last question: when you like search for the answers and you get 0 over a number, what is like the answer?
0.
I put 0, but it was still wrong.
Well, unless it's 0 over infinity, but
It was like is 0 over 2.
yeah, that should be 0.
Maybe
But
I'll have to relook at
yeah.
that.
Also, in the syllabus, or I think it's in the syllabus, Cengage, the company, they have a hotline. You can call them, and they will about the registration because they said they can do that because they don't expect you. Right?
Okay, thank you.
Hi.
How can
Use the what?
like where can I find the tutoring for maths?
For 210. They should have on the online. I don't. Yeah, there's ones on campus here, but usually I know on the online one you look up the course and they'll tell you when they have the tutors available.
And the office hour, if I have a question, can I go to you in person or should I?
Sure. And if you let me know in advance, I'm just in my office. We can get on a Zoom call just as easily. So, yeah.
So I'm emailing you the calculator that's in the syllabus, so like the TI 84 and the other one we can't use those, right?
No, you can't. The only ones you can't use is the one if it says CAS, which is Computer Algebra System.
Okay.
But I always figure if you know how to use that, you're smarter than me. So. But anyway, that's
Awesome, I just want to check. Thank you. I was wondering if ASC lets you rent these.
I don't know of that. I know there's some programs that have them available, but I don't know about generalized programs.
Oh, okay. Okay, cool. Thank you.
Right. And there's also an 800 number or a toll-free number for their technical thing where you could call them up and they'll walk you through because they know what's going on. Because sometimes it might be something in your system that's blocking it or something, but it looks like you're doing okay now, right?
Yeah.
It always does that. Works for me. Good.
Okay, so I have a question on number 5. How do you do like? Yeah, he has the same question. How would you like not this one? This was a practice one, but this is the actual one. So if it's g of f of x, how would you do that?
Okay, so here's f of x. So we're plugging g into x squared goes into the x, so it's x squared plus 3. Of course.
Oh, okay.
And then we plug the -4 in. Or you could.
So it'd be
wait a
like
minute.
16 plus
No.
3.
Actually, I blew it. F is inside, so actually we have to put it into the f first. So it's x plus 3. So we could do -4 plus 3 is -1.
Yeah.
And then square -1.
So square root. So not square root. The square -1, and that's your answer. Yeah. I'll put my
So do the inside out. I flipped it. Yeah. That should.
But if it said f of g of x, it would be that.
Yeah.
Okay.
So we always do the inside part first, and then the outside.
Okay. Thank you.
Yeah, thank you.
You're welcome. Good. 3 people satisfied.
I missed last class. I just signed up. So how do I get onto the website then? Is there a link on
It's in the syllabus. There's some instructions, and then there's also a number you can contact to get the company. So it's Webassign.net. Go to that link, and there's a course code that gets you into this particular code. And
Okay.
just follow through with that.
Alright, thank you. Have a good one.
You too.
I didn't understand that because
Okay, so it's a composition, so that basically you do the inside part first. So if this is going towards, if x is going to 2, what you can do is you can just say, well, let's do the f function first, because it's inside. 2 plus 4 is 6. And then we're going to put it over here into the g function, put in 6, 6. Yeah.
Okay, also in this question, I think there's a, also I forgot, this one.
Mm.
So, after I got the answer,
Yes.
but I submitted the wrong answer, so
You should be able to, it should give you more than one try.
I think it was only one time, so,
It may have been a true or false.
no, so good answer.
Yeah, if it's a fill in the blank, you get 5 attempts. If not, let me know, but send me an email. But there and just send me an email and tell me the question number. I'll take a look at your thing.
But just to make sure the answer would be one. Right?
Yes, yes. Yeah, not 0. So that sometimes you'll see the numerator or the next one becomes 0, but e to the 0 is 1. Yes,
Okay.
just 1.
Okay, thank you.
You're welcome.
Oh, Professor, I had a question right here.
Sure.
So I couldn't figure it out. If it's, this is gonna be negative infinity to the e,
Right.
and
So that's going to become what? It's 1 over e to the infinity,
yeah,
which goes to what?
0, right?
0.
Yeah.
So this goes to 0. So that 5.7 times 0 is 0. So this
Mhm.
becomes 9 minus 0.
So 2 over
2 over 9.
okay.
12,
That should be it. Now, this part,
Mhm.
the limit does not exist. Now, it does exist. The limit does not. The limit does not. The limit does not exist. If I name
It does exist.
it does.
Yeah.
Oh, yes. I can't. That's my
Yeah, but I
problem.
can't click. I tried twice
Oh.
and it's canceled.
They might have. Oh, because it's a multiple choice, they only
Yeah.
give you 2 ties. But what I do with the homework is I pull down your scores. As long as you're at 80% or better, you get all the points.
Oh yeah.
Yeah.
All right. Yeah, I got it right. Thank you so much.
Alright, thank you.
Have a good day.
You too.